Okay, this is our classwork from chapter 4, and we are focusing on adding and subtracting rationals as well as solving rational equations. Now, the LCD is going to be a focus for both of these. I want you to look at this type of problem first. This type of problem, we are simplifying. The directions will say simplify. And there is no equal sign. Okay, so when you are simplifying and there is no equal sign, you are rewriting with the same denominator. Okay, that's your goal. Okay, that's what we're doing when we are simplifying. The directions will say simplify, and there is no equal sign. So we are rewriting with the same denominator. That is what we're doing right here. Okay, so first thing that I want to do is I want to break these denominators down. Both of them can be factored, so we've got to factor that before we can identify our least common denominator. So I have x squared plus x minus 6. So that factors, and that factors to x minus 2 times x plus 3. Okay, negative 2 times positive 3 is negative 6. Negative 2 and positive 3 is positive 1. So that factors to that. Our next rational factors to x plus 3 and x minus 3. Okay, x plus 3 and x minus 3. So our LCD, I am going to start here with my LCD. Okay, so I've got x minus 2 and x plus 3. So then when I look at my second rational, x plus 3 is already accounted for. So I don't have to write that down again. What I do have to write down is the x minus 3. So I've got x minus 3. So now I have my LCD. So I'm going to rewrite these again. So I have 3 over x minus 2 times x plus 3. So my goal now is I look at my denominator and see what I'm missing. So I have x minus 2 already, and I have x plus 3. But what I don't have is this x minus 3. So I am going to multiply the top and the bottom times x minus 3. So if it's missing on the bottom, you have to do it to both. And the reason that we do it to both is because you're multiplying by 1 over 1. That's what happens when we multiply x minus 3 times over x minus 3. Okay, now we're going to do our second one. So I have 5 over x plus 3, x minus 3. So I am going to look at what I am missing over here. So I have the x plus 3. I have the x plus 3 and I have the x minus 3. What I am missing for this side of the problem is the x minus 2. So I am going to multiply the top and the bottom times x minus 2. Okay? So now I can simplify. So my denominator, I have my denominator now as x minus 2 times x plus 3 times x minus 3. You can multiply that out if you want to. Most students do not. Now I'm going to distribute my 3. So I have 3x minus 9. Then I'm going to distribute my 5, and I have 5x minus 10. Okay, I have some like terms. I have 3x and 5x that I can combine, and then I have negative 9 and negative 10 that I combine. So my final answer here is 8x minus 19 over x minus 2, x plus 3, x minus 3. Okay, and again, we are simplifying here. We're simplifying. Okay, let's do the next one. The next one is 3 over 5n plus 2 over 3 minus 7 over 3n. I like to break down the denominators first. This one actually doesn't need the denominators broken down because they're already pretty broken down. So I can go ahead and start finding my least common denominator. So I want to include both the 5 and the n from my first one. Okay, so I move to the second one. My second one has a 3 in it. I don't know why I wrote 5 times 3. I guess my brain was working a little too fast. 5 times n is from my first rational. The 3 is from my second rational, and I don't have that written down yet, so I need to write it down. My third rational has a 3 in it and an n in it, and both of those are already accounted for. Now, I don't need an n squared in this because none of my denominators have an n squared in it. So I don't have to write the n down again unless that was 3n squared. So this one would not be a situation where I have an n squared. Okay, and now we're going to do the same thing again. So I have 3 over 5n. The 5 and the n is accounted for. The 3 is not. So I'm going to multiply this times over 3 over 3. Okay, my next one is 2/3. For this one, I am missing the 5 and the n. So I am going to multiply this times 5 times n, and I've got to do it on my top and my bottom. Now for this one, don't forget this negative. So I like to move that negative to my numerator so that I don't forget about it. So minus 7 over 3/9 becomes plus negative 7 over 3n. Okay, I'm going to look at what's missing, and what's missing in this one is a 5, so I'm going to multiply both times 5. Okay, so my denominator is 5 times n times 3. That's going to give me 15n. 3 times 3 is 9. 2 times 5 times n is 10n. And then I have negative 7 times 5. That's negative 35. I can combine the 9 and the negative 35. So that is 10n minus 26 over 15n. And that is my final answer. Okay. Now we are moving into equations. We are still going to use the LCD, but we're going to use it in a different way. The reason that I know this is an equation is because it has an equal sign. Okay, that is the key indicator. And the directions for this will say solve. Okay, so we are not using the LCD in the same way that we did on our first two problems. Once we find our LCD for this problem, this is when you multiply everything times the LCD. Okay, so our goal here is we are trying to eliminate all denominators. Eliminate the denominators. And we are making the denominator 1, but we don't have any numbers or variables in the denominator to worry about. We're just trying to clear out the denominators and make the denominators 1. So that's our goal here. So that's slightly different than what we were doing earlier. Okay, let's get started. So a couple things that I want to deal with. My denominators do not need to be broken down. I have 2 and then I have 5. I do not need to write down this second 5 because I've already got it accounted for. So I don't need to worry about that again. The other thing that I want us to go ahead and think about, these numerators, they're a unit, okay? They're binomials, so they stay together as a unit. This minus sign, I want to go ahead and change it to a plus and keep that negative in my numerator. I think that that's going to be more helpful. So now what I'm going to do is I am going to multiply everything times 2 times 5 over 1. So that's what I'm doing first. So here we go. I have x minus 1 over 2, and I'm going to multiply that times 2 times 5 over 1. Then I have negative 1 So go ahead and think of that negative as negative 1 times x plus 2 over 5. And I am multiplying that times 2 times 5 over 1. That is equal to negative 3 over 5 times 2 times 5 over 1. Okay, now our goal, what we want to see happen is we want to see those denominators eliminated. Okay, we want to clear them out. So first rational, I've got 2 that I can clear out. Then I have 5 times x minus 1. Okay, my second, I've got 5 and 5 that cancels. Now, I want you to look at this negative 1, and I want you to look at this positive 2. I have to distribute both of those, so be careful there. So this becomes negative 2 times x plus 2. And I got that by multiplying negative 1 times positive 2. Okay, and so I'm actually distributing a negative 2. For my last one, I have 5s that clear out. I'm left with negative 2, or negative 3 times 2, and that gives me negative 6. Now I can solve. 5 times x is 5x. 5 times negative 1 is negative 5. I distribute my negative 2, and I get negative 2x minus 4. That equals negative 6. Okay, 5x minus 2x is going to be 3x. Negative 5 minus 4 is negative 9. Okay, I add 9 to both sides, and I'm left with 3x equals 3. And when I divide both sides by 3, I'm left with x equals 1. So my final answer to this one is x equals 1. Okay, let's move on to number 4. Now we're doing the same thing that we've been doing. So we're trying to clear out our denominator. So we've got an equal sign, we're solving, we've got to clear out our denominator. But now we have another layer. We have x's in the denominator, and anytime that we have an x in the denominator, there are some values that it cannot be. Okay, so what values are undefined? And anytime that we have that, anytime that we have a variable in the denominator, we have to figure out what that is. Okay, and our values are going to be undefined for anything that makes the denominator 0. So for both of these, x cannot be 0. Okay, so all I did was I set the denominators equal to 0 and solved to see what gave me 0. So for this problem right here, x cannot be 0. X can be anything else, but it can't be 0. So if I get 0 here, what I have to do is I have to throw it out. Okay, so we have x cannot equal 0. Now we're going to find our least common denominator. Okay, my first denominator is 4x. I'm going to rewrite that 4 as 2 times 2 times x. Okay, I could have gone ahead and rewritten the whole problem and done that. My second denominator already has a 2 in it. My LCD already has a 2 in it, so I don't have to worry about that. My third has a 5 and an x. Now, I don't have a 5 written down yet, but I do have the x. So I don't have to write that x down again. And again, in this one, I'm not going to have an x squared here because none of my denominators have an x squared. I only have to have the x squared is if it shows up twice, if I've got x times x in a denominator, and I don't have that here. So now what I'm going to do is I'm going to multiply everything times 2 times 2 times 5 times x. Okay, so I have 5 over 4x, and I am going to multiply that times 2 times 2 times 5 times x over 1. Then I have plus 3 over 2. I'm going to multiply that times 2 times 2 times 5 times x over 1. and that's equal to 7 over 5x. And so I multiply that, 2 times 5 times x over 1. Okay, now I can start simplifying. 2 times 2 is 4, so 2 times 2 on the top and 4 on the bottom. Then I have x and x, so then I'm left with 5 times 5. Okay, my next one I have a 2 that cancel out, so then I am left with 3 times 2 times 5 times x. Lots of stuff in that one. Okay, then I have a 5 and an x in the denominator, and those cancel out in the numerator, so I'm left with 7 times 2 times 2. So I have cleared out my denominator, and now I solve. So I have 5 times 5 is 25. 3 times 2 times 5 is 30. And then we've got our x, so I have 30x. 7 times 2 times 2 is 28. Okay, I am subtracting my 25 from both sides. So I'm left with 30x equals 3. I divide by 30, and my x value is 1 over 10. Okay, now the only number that x could not be was 0, so we're in good shape. I don't have to worry about throwing anything out because my undefined value is 0, and I did not get that for an answer. Okay, so let's move on to the next one. This one is negative 3 over 4n minus 1 equals negative 2 over 3n plus 11. So I can't really factor my denominators, so I'm going to go ahead and identify what my LCD is. So my LCD is going to be both of these binomials. I'm going to have 4n minus 1, and I'm going to have 3n plus 11. Okay, some students may look at this and they will say, well, Alicia, why can't I cross multiply? And I do want you to understand in this particular problem, you can cross multiply. The issue is in that a problem like this, you can't. Or a problem like this, you can't. So don't get in the habit of cross multiplying. This is actually a rational set equal to another rational. So you can cross multiply. I recommend that you don't cross multiply because you may get confused later on. Now, the next thing that I want us to determine is what values can x not be. Okay, what values can x not be? And I do that by setting each denominator equal or not equal to 0 and solving. So I'm going to have 4n minus 1 can't be equal to 0. So I have 4n can't be equal to 1. Then I divide by 4. So my undefined value for one of my denominators is 1/4. So I'm going to put this down here at the bottom. N cannot be 1/4. Okay, now we've got to do the second denominator. So my second denominator is 3n plus 11. Cannot be 0. So you just set that equal to 0. You take that denominator and you put it equal to 0. The line through it says cannot be. So I'm saying 3n plus 11 cannot be equal to 0. So then I have 3n cannot be equal to negative 11. I divide by 3, and I have n cannot be negative 11 over 3. So n cannot be 1/4, and n cannot be negative 11 over 3. I realize I wrote that down in the bottom, and so you may not be able to see that as much, but if it becomes an issue, I'll move it back up. Okay, so now what we're going to do is we are going to multiply everything by my common denominator. So that is 4n minus 1 times 3n plus 11. So I'm multiplying everything times that. So I've got negative 3 over 4n minus 11 times 4n minus 1 times 3n plus 11. Okay, that is set equal to negative 2 over 3n plus 11. We are going to multiply that times 4n minus 1 times 3n plus 11. Okay, so now we get to clear out our denominators, 4n minus 1 and 4n minus 1. I'm left with negative 3 times 3n plus 11. Okay, 3n plus 11 clears out. I'm left with negative 2 times 4n minus 1. Okay, at this point, we have something that we can manage pretty easily. Negative 3 times 3n is negative 9n. Negative 3 times 11 is negative 33. Then I have negative 2 times 4n is negative 8n. Negative 2 times negative 1 is plus 2. Okay, so now I'm going to solve. So what I'm going to do now is I'm going to add 8 to both sides, 8n. Okay, so now I have negative 1n minus 33 equals positive 2. I add 33 to both sides, and I end up with negative 1n equals 35. Okay, I'm going to move my fractions because you guys know I write big. So I have negative 1n equals 35. So I'm going to divide by negative 1, and I get n equals negative 35. Okay, that is not one of our values that has to be thrown out. So our final answer here is n equals negative 35. Okay, let's move on to number 6. Okay, for number 6, sometimes students get a little bit confused because there's only one denominator. Only one of these terms has a denominator. Remember that this n is over 1 and this 4 is over 1. So my LCD is just n, okay? And that also means that my undefined value is 0 because that denominator can't be 0. So I am going to multiply everything times n over 1. And I think what happens with this particular problem is that students are concerned because so many of them don't have a denominator. And then we end up with a quadratic, and so students start getting confused. But you are correct. The least common denominator here is just n. And so we multiply everything times n over 1. Okay? And so that is what I have done, is I have multiplied everything times n over 1. When I simplify this, I end up with n squared. And then I have minus 5, because my two n's cancel, equals 4n. So I have a quadratic. The way that I know that is a quadratic is because I have something raised to the second power. That is how I know that that is a quadratic, and that is how I know I have to be careful and not try to solve it as a linear function because it's a quadratic. So what I'm going to do is I'm going to subtract this 4n from both sides, and I am going to end up with a trinomial. I'm going to have n squared minus 4n minus 5 equals 0. Okay, this can be factored. N minus 5 and n plus 1. Negative 5 plus 1 gives me negative 4. Negative 5 times 1 gives me negative 5. I set each one equal to 0. N minus 5 equals 0 and n plus 1 equals 0. And so my values, and both of these are correct, are n equals 5 and n equals negative 1. So I can have two correct values. I do have to check and make sure I don't need to throw any of them out. I don't need to throw any of them out because neither one of them are 0. So I am in good shape. Okay, let's move on to the next one. Okay, I have 6 over x minus 4 minus 4 over x plus 3 equals 8 over x minus 4. So what I'm going to do here is I'm going to go ahead and start identifying my LCD. Okay, I'm going to write down x minus 4 first. So I have x minus 4. Then I'm going to write down x plus 3. Okay, and I do not need to write down x minus 4 again because I've already written it down. So that is already accounted for. The next thing that I like to deal with is that minus sign. I want to go ahead and make this a plus sign and move the negative to the numerator. Okay, my last thing is I'm going to figure out what my undefined values are. So I've got to look at each denominator, and I've got to determine what values can x naught be that would make my denominator 0. So x minus 4 can't be 0. X plus 3 can't be 0. And I don't have to do x minus 4 again because I've already done it once. So x cannot be 4, and x cannot be negative 3. So I'm going to write this down at the bottom. So x cannot be 4, and x cannot be negative 3. Those are the values that x cannot be. Okay, so now I am multiplying everything times my LCD. And my LCD is x minus 4 and x plus 3. And just for the sake of space, I'm going to go ahead and erase that. So I have x minus 4 and x plus 3. Okay? So I have 6 over x minus 4 times x minus 4 times x plus 3 over 1. Then I've changed that to plus negative 4 over x plus 3 times x minus 4 times x plus 3 equals 8 over x minus 4. And I am multiplying that times x minus 4, x plus 3. Okay? So I have multiplied everything by my LCD. So I'm going to start marking or canceling things out to eliminate, clear out everything in my denominator. So now I have 6 times x plus 3. Then I have plus negative 4. My x plus 3's cancel, so I have negative 4 times x minus 4. Okay, here my x minus 4's cancel, and I'm left with 8 times x plus 3. Okay, so now I'm going to distribute my 6. So I have 6x plus 18. Now I'm going to distribute my negative 4. So I have negative 4x plus 16 equals 8x plus 24. Okay, I'm going to combine like terms on the left-hand side first. So I have positive 6x and negative 4x. That gives me positive 2x. Then I have positive 18 and positive 16. That gives me positive 34. Okay. So now I'm going to go ahead and subtract 8x from both sides. That leaves me with negative 6x. And I'm going to go ahead and subtract 34 in that same step. So I am going to end up with negative 6x equals negative 10. Okay? When I divide both sides by negative 10, I end up with x equals positive 10 over 6. And that's because they're both negative. A negative and a negative make a positive. And I get x is 5 over 3 when I simplify. That is not either one of my undefined values. And so I don't need to worry about that. I am going to leave that as my final answer. And then I'm going to move on to the last one. Okay. We are solving. This, I am going to rewrite this because I've got several denominators that I can break down. And by breaking down, I mean I'm factoring. So I'm going to have 1 over 3x minus 1. That one can't be factored. Then I've got x minus 2 over 9x squared minus 1. 9x squared is a perfect square, and 1 is a perfect square. So that can be factored to 3x minus 1 and 3x plus 1. So don't let that confuse you. Okay? Then I can factor this denominator by factoring out a 2. So when I factor out a 2 here, I get 3x minus 1. Okay? Now I'm going to find out what my LCD is. Okay, I have 3x minus 1, so I'm going to start there. Then for my second, so that is covered. Then I've got 3x minus 1. I'm going to have to write down 3x plus 2, or 3x plus 1. So I don't have that one yet. I have 3x minus 1, but I don't have 3x plus 1. Then for my last, I've got 3x minus 1. That's already covered, but the 2 isn't. So I've got to multiply this all times a 2. Okay? Now I want to look at undefined values. My first one is 3x minus 1 cannot be 0. So I have 3x cannot be 1. And so x cannot be 1/3. Okay, so that's one of my undefined values. Now, I've already done 3x minus 1, so I don't have to do that one again. I do have to do 3x plus 0, or I'm sorry, 3x plus 1. So 3x plus 1 cannot be 0. So I have 3x cannot be negative 1, and x cannot be negative 1/3. Now, I know I've still got my 2 there, but I don't have to worry about that because it doesn't have an x in it. So x cannot be 1/3 and x cannot be negative 1/3. So if I were to get either one of those for this problem, then I would have to throw it out. Okay? So now we're going to multiply everything by this LCD. 2 times 3x minus 1 times 3x plus 1. Okay? So I have 1 over 3x minus 1. I am multiplying that times 2 times 3x minus 1, 3x plus 1. That's all over 1. Then I have plus x minus 2 over 3x minus 1 times 3x plus 1. Okay, I am multiplying that times 2 times 3x minus 1 and 3x plus 1. And that is all over 1. And that is equal to 7 over 2 times 3x minus 1. And I multiply that times 2 times 3x minus 1 times 3x plus 1. And that is over 1. So now I can start clearing everything out. So I have 3x minus 1 and 3x minus 1. So I've got a 1 here and a 2 here. So if I multiply those two together, I've got 2, and then I'm distributing that 2 to 3x plus 1. So that's what I have left there. Okay, for my second one, 3x minus 1 and 3x plus 1 cancel out. I am left with a 2, and so that 2 has got to be distributed to x minus 2. Okay, then my third rational, my 2 and my 3x minus 1 cancel, so I am left with 7 times 3x plus 1. And so now I've got all my denominators cleared out, so now I just have a equation to solve, and it's linear because I don't have any x squared. So 2 times 3x is going to be 6x, 2 times 1 is 2, 2 times x is 2x, 2 times negative 2 is negative 4. I just distributed both of those. 7 times 3x is 21x, 7 times 1 is 7. Okay. 6x plus 2x is 8x. 2 times negative 4 is negative 2. Or 2 plus negative 4. Then I have 21x plus 7. I'm going to subtract 21x from both sides. And I'm going to go ahead and add 2 to both sides. So I'm doing that at the same time. The 21x and the 2's cancel. So I am left with negative 13x equals 9. I divide both sides by negative 13. So I have x equals negative 9 over 13. Okay, so that is the end of the solutions for this. I hope that helps, and I will see you next week.